Okay, let's talk parabolas. Let's talk parabolas. So I know we talked about this, but it's been, I mean, gosh, it's been almost a month, with that long break. So we need to go back and probably hit some of this stuff again for sure. So let's go back to the beginning and just it'll go a little faster this time, but let's review how we can come up with and use the standard form for equation for a parabola. So back in Algebra 1, you guys did a lot of work with parabolas, and sort of the reference parabola or the parent equation that you probably always used was y equals x squared. And that's just a normal plain Jane parabola with a vertex at the origin that opens up, right? Okay, everybody remembers that one. The important thing I want you to recognize here for this, all this page is about here is reminding you that you get a normal parabola where the u either opens up or down. We might say it's a vertical parabola because either it's up vertically or down vertically when it's the x variable that's being squared. Okay, because in a quadratic equation that gives us a parabola, only one of the two variables is squared. So in this case, y is not, but x is, right? That's normal. You can get a parabola that's tipped on its side, so it either opens to the right or it could open to the left if it's the y variable that's being squared. Now that's not the normal one. That's the one that you probably may not have ever even seen before, but it's no big deal. Right? Okay, so these are the ones you dealt with in Algebra 1, and maybe slightly more complicated. But what we want to do today is look at things a little differently. We want to look at the standard form equation of a parabola that allows us to really easily identify its graph. Okay, and that's the one that looks like this for a vertical parabola. And once again, vertical, we're talking about either like that or like that. It looks like this. X minus h squared equals 4p times y minus k. So let's compare this to what we talked about yesterday. Yesterday we talked about circles, right? And we said that the standard form equation of a circle was just x minus h squared plus y minus k squared equals r squared, right? H and k represented what for the circle? The coordinates of?
The center.
The center, good. Okay, so that tells us where the circle is. And then r just told us how big it is, right? What the radius of the circle was. Same kind of thing with a parabola. H and k represent the coordinates of what do you suppose? For a parabola. What would be the one unique point on a parabola?
Where
Yeah, the vertex, and we call it the vertex, right? So it's kind of the point of the parabola, right? And if you want to think about it in terms of symmetry, if that's our parabola has folding symmetry about an axis, right? Right, Hannah? Agree with that?
Yep.
Okay, so where the line of symmetry intersects the parabola, that's the vertex, right? So it's the point that would, if I folded the parabola on itself, it's the one point that wouldn't move, right? Okay, so that's what H and K tells us. P is a little different. P tells us, just like R told us the shape or the size of the circle, P tells us kind of the shape of the parabola. And here's the picture we use, and we drew this a while ago. Do you remember going through that whole, I've still got that, I had that geometer sketch pad, and we talked about a parabola as being the locus of points equidistant from a focus and a directrix. Do you vaguely remember that? Sort of, kind of, maybe, right? I'm not going to bother pulling that up. I can kind of refresh your memory a little bit on it, but here's what that looks like then. So if I want to graph this parabola, or I want to look at the graph of this parabola, if this is what we call the directrix, it's just going to be some horizontal line. And this is what we call the focus. Then the parabola is going to be the locus of points that are equidistant from both of those. And so it's going to be, the vertex is going to be the one point that's exactly halfway between the focus and the directrix lined up vertically. And all the other points just end up looking kind of like that, right? And what we know, I didn't draw this very well, of course, but that distance right there should be the same as that distance right there, for example, right? Every single point on that parabola is going to be the same distance from the focus and from the directrix. Okay, that's what a parabola really means. It's that set of points. Okay, so then this is what we call the vertex, and its coordinates are h and k. So there's those two parameters. What about p? Well, p is just going to be the distance from the vertex to the focus. So always think about it as a vector or an arrow. So if you start at the vertex and we move to the focus, that's p. It's positive if it's moving in if the arrow is pointing in the positive direction. So for example, if the parabola is opening up, that means that the focus is above the vertex, and so the arrow is pointing in the positive y direction. So p would be positive. What if we flip this around? Well, if the focus were below the vertex, p would be negative, because the arrow would be pointing, if we start at the vertex and travel down to the focus, we'd be pointing in the negative direction. Okay? So when you think about this, one way to also remember what the parabola always looks like in relation to the focus, which is a point, and the directrix, which is a line, the parabola always swallows the focus. It's always going to open towards, so it engulfs or swallows the focus. Okay? That's the picture we need. What we want to do is we're going to start off by trying to come up with the standard form equation of a parabola if they give us, for example, the coordinates of the focus and the equation of the directrix. Okay, so let's try something like that. Okay, they're giving us the line, right? That tells us everything we need to know, right? What kind of line is that, by the way? If it's a y equals a number, what kind of line? Horizontal or vertical? Horizontal. And the way you can always remember that is because the line is going to cut the y-axis at -5. For a line to cut the y-axis, it couldn't be vertical. It'd have to be horizontal, wouldn't it? Right? So let's just graph the line. Let's plot the point, and then we can create a little sketch. It doesn't have to be accurate at all. We just have to get a couple things right. So if this is my horizontal line, y equals -5. What about the focus? Is it above or below the directrix? Because this is the directrix right here, right? How would you know? Say it again. It's above. How come? Because right, and which part of the? So how do you? I mean, it's a simple question. I know you're probably thinking, well, wait, yeah, just the y coordinate, right? The coordinates are telling us if this has a y value of 3 and that y value is -5. Obviously, the point's above them, right? So the focus is going to be up here somewhere with coordinates 2, 3. Okay, so this is going to be a vertical parabola, isn't it? Right? Because the vertex is going to be in here, and it's going to have to open up to swallow the focus, right? Does that make sense? So we can always make that association. If the directrix is horizontal, that means the parabola is going to be a vertical one, and vice versa, right? So if we sketch the parabola, we already know it's going to look something like that, sort of, right? We just need to know what are the coordinates of the vertex and what's the value of p. Well, how am I going to find the coordinates of the vertex? What do we know about the relationship between the focus, here's our focus, call it F, and our vertex, V, and the directrix? Equidistant, right. Okay, so then what are the coordinates of the vertex going to be? One of them is a freebie. 2, yeah. How come? The x-coordinate has to be 2. Yeah, because it has to line up with the focus, doesn't it? Right? So if it's a vertical parabola, we know that the x-coordinates of the focus and the vertex are going to be the same because they have to line up vertically, right? The only one that we have to work for a little bit is the y-coordinate. So what about the y-coordinate?
1.5?
Say it again.
1.5.
1 point. How'd you get that?
Divide the 3 in half.
Divide the 3 in half. Okay. But the directrix is at -5. See what I'm saying? That you were thinking in terms of the x-axis. That would have been correct.
It's in negative
It is -1. How'd you get that?
1. In between 3.
Okay, so yeah, so we found the number that's in between 3 and -5. That's halfway in between. Now let's talk about that process for just a second. There's a bunch of ways you can do this, but let's see if we can come up with a really efficient way of finding the middle number of two numbers. Given two numbers, can we find the middle number? What's one way to do this? Okay, so you could say it again.
Add the 2 together.
Oh man, you jumped right to the answer. That's good. So when we want to find a middle number, there's different kinds of middles that we define in math, right? We can talk about a mode is one kind of middle and a median is one kind of middle. But when we want to talk about the middle of two numbers, we're talking about a mean or an average. That's really all it is, right? When we average two numbers, we're just finding the middle value. Agreed? Like if you were trying to find, let's say that your profits one year were $100 and your profits the next year were $400. You want to find your average profits. Aren't you just finding the middle value of those 2 years, right? How would you do that again? Add them and divide by 2. Yeah. Okay, so all we got to do is add 3 and -5, which is -2 divided by 2, -1. Okay, so that's good. That tells us 2 of our 3 parameters right there. What's h going to be? Cassie, what's h?
2.
2. Yeah, because it's, remember, the coordinates of the vertex are h and k. So that's h and that's k, right? Okay, what about p? P is just a little bit trickier. It's not horrible. What did we say about p, though? It's the distance starting where and ending where? And ending at the focus. Yeah, so if we start at the vertex and end at the focus, how far do we go? Went from -1 to 3. So 4. So 3 minus -1 is +4. And we know it's positive. We can kind of check ourselves because the parabola opens up, which is the positive direction. Okay? So now we know the 3 parameters. All we've got to do is just plug those into our standard form, right? And that's it. Standard form for a vertical parabola. Okay, so let's, I know this, I'm probably oversimplifying this, but let's just take this slow here. So we've got x is the variable that's being squared because it is a regular vertical parabola. So we get quantity x minus h squared equals 4p times y minus k. We just plug that stuff in. So if I plug in 2 for x, I get what? X minus 2 squared. Done. What about 4p? If p is 4, what's this number going to be? 16. Yeah. 16 times y minus negative makes it a positive 1. That's our answer. Okay. And there might be a temptation to want to simplify this by distributing the 16. No, we don't want to do that. We want to leave it like this because this is the form that communicates to us the vertex is at 2, -1, and p is equal to 16 divided by 4 is 4, right? Okay, so that's standard form. All right, let's try one more of those. But I want to pick a different, hang on, I don't like this one. I'm just going to change the directrix. I'm going to make the directrix the line x equals 3. Actually, I'm going to make it x equals 4. Okay, so now let's think about this. Is that a horizontal or a vertical line? It's a vertical line. So is this parabola going to be Vertical or horizontal? It's gonna be horizontal, it's gonna be tipped on its side, isn't it? Right, because now we've got a vertical, directrix. So real quick, let's come up with, let's come up with what our standard form would have to be. Okay, it's gonna change a little bit. Instead of being the one that we're used to, that we just talked about, x minus h squared equals 4p times y minus k. If the parabola is tipped on its side, it's the other kind, where the y is the variable that's being squared. So what changes would I make to this? And they're pretty simple and predictable. What should this expression become? The one that's being squared. Instead of x minus h squared, it should be, what do you think?
Y minus h squared.
Y minus, what's y minus k squared? There we go. So this is going to become y minus k squared. Well, the p means the same thing. That stays the same. But what's the y minus k is going to become? Yeah, x minus h. Okay, so that's the standard form that we want for a sideways parabola, right? Okay, so what are we going to do first? Probably start with the directrix, right? So the directrix is the vertical line, x equals 4, so it cuts the x-axis at 4. Here's the focus. Is it going to be to the left or the right of the directrix? How come? Because of the 7? Okay, but that's the y-coordinate, right? The x-coordinate for the line is 4. The x-coordinate of this point is 0, so it's actually going to be on the left, isn't it? If I draw this, I get something like, there's my directrix, and there's my focus. It has coordinates 0, 7, right? That make sense? Right, if I want to draw the, like, if I were to draw in the x and y axes, I guess like it would look like this, wouldn't it? There would be the y-axis and the x-axis would be down there, but we don't really need them. It's not important. It doesn't really add anything. In fact, I think it might even just complicate the situation. You don't really need them. We just need to orient those points. Does that make sense, though? That x value is less than that one, so it has to be to the left. So then the vertex has to go in the middle, right? So there's V. Now, what are the coordinates of V going to be? If it's a sideways parabola, the vertex and the focus line up how? How do they seem to line up? How would we describe that maybe? Horizontally. Yeah, they line up horizontally. So what coordinates are going to be the same this time?
7.
The 7. Yeah, the y coordinates have to be the same, right? Because they're lining up horizontally. So we know right away the y coordinate is 7, but the x coordinate has to be the middle one, doesn't it? So what's the middle of 0 and 4? 2. 0 plus 4 is 4, divided by 2 is 2. So there are the coordinates, right?
Would you ever get a decimal?
Say it again.
Would you ever get a decimal?
I mean, you could. I probably won't get a lot of those just because I don't want you to focus on the written. But you could. Sure you could. Or a fraction. What about P? In which direction is this parabola going to open? Left or right? To the left. It's got to swallow the focus, doesn't it? So it's going to go like this. Right? So should P be positive or negative, do you think? Negative, because it's opening in the negative direction. And it is. If we draw our arrow from V to F, what's the length of the arrow? 2, and it's going in the negative direction. So this tells us P is negative 2, right? Make sense? So now we got all our parameters, don't we? So what's the value of H?
7.
No. 2. Yeah, because we're looking at the vertex, aren't we? It's the vertex that has coordinates hk. H is always gonna be the x coordinate, k is always the y coordinate. It's alphabetical, h before k, x before y. So 2 goes in for h. What's the value of k? 7. And what's the value of p? Negative 2, good. That's all we do. Plug that stuff in and we're done. So what's our answer look like then for this one? If we want to write it in standard form, that's going to give us y minus 7 squared equals, what's that number going to be? Negative 8 times x minus positive 2. That's it. Okay, make sense? Okay. All right, next kind. Okay, this is it. I'm in the process of fixing these. If it says convert the equation, just so you know, these should be fixed by end of lunch. So if it says convert the equation to standard form and there's no equals sign, it means there's supposed to be an equals 0 on there. I'll fix them so they show up. If you get one that doesn't, just know that that's the way it's supposed to be. Okay? And if you like redo it and pull up another problem by that time, if you've already started the assignment, for example, if you redo it and pull up another problem, the 0 will be there. Okay. All right. So let's look at this one then. We want to convert this equation into standard form. Okay. This is an equation that would end up being a parabola, but it's just not very convenient. We want to write it in standard form. So what's the variable that's being squared here? And this one, x. So then this is going to be the one. See if you guys try writing this down. So write down without looking. Try just, covering up your notes, so just try to internalize this, memorize. Try to write down the standard form equation for a parabola where it's the x variable that's being squared. Did you get that? Okay, that's the form we've got to get it into, right? That's our standard form, so we got to go from there to there. All right, so what's the part of that that's going to be a little bit tricky? Well, I mean, the x's are being squared, so I've got to complete the square, don't I? Because I've got to create a perfect square factor here, right? Which means I've got to go through that process, but we're getting pretty good at that. You guys have done harder problems like this in the past. So I'm going to group all of the x terms together, right, on the left side. So I'm going to get an x squared minus 6x space, right, because I'm going to have to add a number to create a perfect square trinomial there. Everything else goes on the other side. All we want on the left side is the x stuff, right? So on the other side, we got to chase these terms away. So what am I going to get over here? How do I get rid of the 4y? What do I have to do to both sides to push that right? Add 4y. Good. So I'm going to get a positive 4y, and then what about that 5? Minus 5. Okay, that's where I'm starting, right? And so to complete the square, Nick, what's this perfect square factor going to end up being that goes with those terms? X minus 3 quantity squared. Good. Which means, what's the blue number that has to get added to both sides to make that happen? 9. Right? And so, what that's telling us is that if I were to factor x squared minus 6x plus 9, I'm going to get x minus 3 times x minus 3. And it works. Think about the magic numbers. What two magic numbers multiply to positive 9 and add to negative 6? Negative 3 and negative 3. There it is. X minus 3 squared is just x minus 3 times x minus 3, right? So we completed the square. What about the other side? What are we left with over here? Well, we're left with 4y minus 5 plus 9 is plus 4. Okay. But look what we want to do. We want to get this in the form some number times the quantity y minus something. So whatever number is in front of the y, we have to factor that out of the right side. In other words, undistributed. Okay? So what's that going to give us on the right side? If I factor out a 4, well, what am I left with? Well, I'm left with a y here, aren't I? If I undistribute it, obviously. 4 times y, if I were to distribute, gives me 4y. What goes over here, though? What am I left with if I undistribute a 4 from a 4? Same thing as dividing. I'm just dividing 4 away from each of those. 1. Okay. And once again, the way, we haven't done this in a while, but the way I like to think about this when I'm factoring something out, remember we talked about greatest common factors earlier in the year, is, okay, if I'm factoring out a 4, then I'm just asking the question, okay, what am I left with? 4 times y is 4. 4 times what is 4? 4 times 1, right? Does that make sense? Okay. And so we're done. That's in standard form, isn't it? Okay, why might that be useful? Well, once it's in standard form, we should be able to identify what h and k and p are, right? So what's h? H is what? 3. Good. It's because remember, h is the number that's being subtracted from x, right? So it's always going to be the opposite. If I think of that as being a sign in the middle, it's always the opposite of that sign, isn't it? We're subtracting, so it'd make it positive. So h equals 3. What's k? Good. -1. Good. So we know those are the coordinates of the vertex. Now, what's p? This is equal to 4p, isn't it? Right? So 4p equals 4. So what's p? 1. All I have to do is just divide that number by 4, right? I got it. That's all I need to graph this thing, for example. I just know that it's got a vertex at x equals 3, y equals -1, and p is positive, and x is being squared, so it's going to open up or down. What do you think? Right, this is going to be a vertical one, isn't it? Because it's the x variable that's being squared. Positive p, if it's a vertical parabola, is it opening up or opening down? Up. Yeah. So we would just know that it's going to look basically like this. It's an upward opening parabola with a vertex at 3, -1. If we really want to get technical, it tells us that the focus is only 1 away from the vertex. But rarely do we have to get that technical. Okay? All right, try one. Try that. Okay. So you complete the square to convert that into standard form. Okay,
Mr. Riley, I know some I don't know why.
Oh, you don't need to, you're good, see,
Oh.
because, no, you're fine, because you don't have to, just have that by itself.
Oh.
So then, divided by 4 is just 4.
Oh, I don't know why.
See what I'm saying? Well, you would, so this is that's supposed to be the last year, right, because half is positive.
So it's positive or negative 6?
So that's why.
Well, h is -6, but it's x plus 6 squared, right?
okay, I'll visit this half next. Let's take a look at this one real quick. Okay, let's see. Talk me through this a little bit. Cassidy, what's the variable that's being squared?
X.
X. So what are we gonna do?
Yeah.
I saw you did it, so I'm gonna group those terms go on the left, right, the x terms.
Yeah.
So x squared plus 12x, what else do I need on the left side?
Plus 36.
Space, right? Gotta have space.
Yeah.
Gotta have my space.
Yeah.
And then on the other side, what am I gonna get?
16y minus 36.
Good. Okay, so there's the setup stage, right? Now we're set up to complete the square. What is my perfect square factor gonna be? X plus 6, which means in order to get that, I have to have what number here? 36. So I gotta add 36 to both sides, right? To create, so what I did then on the left side is, I created a perfect square trinomial that factors the way I want it to. Okay, on the right side, well, look what happens. The -36 and the 36 cancel. And I just get 16y, I'm done. There's nothing, I don't have to undistribute anything because there's only one term, right? Okay, but here's the part I want to make sure we understand now. What's h? -6 from here, right? What's k? That's a little tricky. It's actually really easy, but it's tricky at first. No. K. What's the number being subtracted from y? Is there one? Ah, it's 0 then, isn't it? Right. Because this is the same thing as saying y minus 0. We don't write that, of course, but do you see that? Okay, and then what's p? 4. Good. 16 divided by 4. Good. Okay, so you got it. Okay, last one. What about something like this? Okay, what about that? Now think about this. It says choose the graph of the parabola and focus corresponding to the equation below, right? That's not very helpful. If I've got the equation written in that form, I can't see, I don't know. I don't know what the coordinates of the vertex are if the parabola is written with that equation. I've got to put it in standard form, right? So this time, what's the variable that's being squared? The y's. Okay, so I'm going to collect y terms on the left, right? And all the other stuff goes to the right. And then we'll complete the square. We don't have a lot of time, but see if you can at least get a start on this. So maybe it's helpful just to kind of have in the back of your mind what you're striving for. What's the equation that you're trying to get look like? What's the standard form equation going to be when the y's are being squared? What's it look like? The y's are being squared, so I get the quantity y minus what?
6.
Okay, don't even focus on this. I'm just saying in general. We want the standard form equation for a sideways parabola where the y's are being squared. Okay, I'll get y minus k squared equals 4p x minus h. That's what we want to put it into that form, right? Okay?
Yeah, good. No, no. Let's have them, so that's.
I just didn't know if I was doing that.
Oh, no, you're fine. So that's.
So we can like put it in this way.
Now, okay, so now you got the y's are big, right? So now you're gonna plug, see, that's an external. I want the y terms on the left side, so I can get, see what I'm saying? Okay, and the x's go to the other.
How'd you get this would be a 52?
Oh, how did
I don't know.
Wait. Is K gonna be?
Just factor our
I'm not there yet. I kept writing 5 instead of 52. So I was over 6.
Wait, what's the answer to 6?
No.
Negative 52. 8. Plus negative 52. Oh, negative.
So it's,
Wait.
yeah, so it's negative 52. Now. 4. Negative 62. So then you're gonna get.
It does. I'm tired of it. It's more, I'm tired of it. Like, they're just kind of like.
So you're saying.
Everybody appreciate it.
You see how this works out?
And it's really annoying. And like, if we would run out of designs or something, I would just shave it off. And then.
Does that make sense?
Okay, so, oh, here we go, real quick, let's make sure we get this one done. I'm just gonna zip through this. So, if I collect the y terms on the left side, everybody agree I get y squared plus 12y space, right? Equals, if I push the other terms over there, I'm going to add 16x to both sides, so I get a positive 16x, and I'm gonna subtract 52, like so.
Yes.
Okay, so then my perfect square is going to be half of positive 12 is 6, so I get y plus 6 squared, which means I've got to add the blue number 36 to both sides. And so what do we get then? I get 16x, and negative 52 plus 36 is minus 16. Here's the part that, it's not hard, but here's the part that maybe we haven't had as much practice with. what do I get if I factor out a 16? I'm just dividing it away from each term. I get 16 times x minus 1. Everybody see that? Because if 16 over 16 is 1.
However, we get a different number.
Okay, so what if that number were like a 32? Then I would have had a 2. Because 16 times 2 would have been 32. Okay, see what I'm saying? And so that's my answer. So then all we'd have to do to find this parabola is know that h is 1, k is negative 6, right? And p is 4, right? Does that make sense? And we know that it's going to be a horizontal parabola. Okay? All right, good stuff.